Hello everyone, my name is Sai Kiran and welcome to my YouTube channel, The AR Guy. In this video, we will be looking at all the new features released by Google in the recent Google I/O, especially targeting augmented reality, AR Core, and Unity. So the very first thing that stands out is Geospatial Creator. This is going to blow your mind because in terms of possibilities of what we can achieve with this is awesome. And until this point of time, it was really difficult, and there was no official or the go-to solution. I mean, of course, we have for world scale AR, we have Niantic SDKs, but it's mostly based on crowdsource data, wherein this is based on Google's own map tiles and something called it also relies a bit on third-party packages like CCM to render the 3D tile maps in Unity. But nevertheless, this is the better approach for creating world-scale GR. So before getting there, if you really want me to do a video, I mean, in fact, I'm planning to make an in-depth video on creating an AR application based on these features. So don't forget to subscribe and enable the notifications. So before getting the details, let's roll the intro of the channel. Okay, so let's get started with what Geospatial Creator is all about. So Geospatial Creator enables you to visualize the 3D photogrammetric data of the whatever the location that you put in inside Unity. It's better to look at what I'm trying to say rather than me explaining you. For example, so I have installed the latest AR core and the dependencies that AR core extensions and the dependent CCM package and all that. I'll make a other video explaining in detail. So here, what I've done is I've just searched for Eiffel Tower on Google Maps and I've right clicked on it and copied the latitude and longitude and just copied here, and voila, you get all the photogrammetric 3D data of that particular location, and you can input the height, I mean the altitude and all. You can, how cool is that? So this is Google Earth style view where you can roam around the city or the what are the location that you have entered. This is really cool. You should try this. Okay, so this is one part. So this is only for the visualization part because uh, you don't have to do the guesswork as a developer in terms of where exactly the object, the digital element will be placed. So this will solve a lot of issues in terms of placement of the object in here. So let's see what type of anchoring or methodologies or placements are supported with this. So basically, there were three types of anchors that you can do. This is, I mean, WGS84 anchor is like a bit of legacy anchor, which was in previous versions of ARCore, I guess, where you have to manually input latitude, longitude, and also very importantly, altitude, because in terms of altitude, if you don't know the mean sea level, it's really difficult for the application or even for the human being to specify altitude. It was more of a trial and error method, but with the introduction of terrain anchors, what it basically does is you just have to specify the latitude and longitude like I did here, and it will take care of the rest. For example, I have placed a cube here at the base of the Eiffel Tower, and I've added this Geospatial Creator anchor. As you can see, there are multiple anchor modes that you can select. If you select manual altitude, you have to manually input the altitude, and if you have selected terrain anchor, what it does is wherever the latitude longitude that you have given, it will basically take the base of that particular latitude and longitude, it will place it there. And if you want the object to float, and you can view that offset by increasing this value. You can see by even though I increase the value, the change is not being affected. With the cube is still there. It is because this whatever the altitude offset will only takes place during the real time runtime thing. But whereas in this is for our visualization in the editor. So the application will ignore this altitude in runtime, will take this one. If I make it 10, what it basically does is, while once the application detects the location based on the VPS, it will place the cube 10 meters above the ground level. So this, now coming to rooftop anchors, it basically does something similar to terrain anchors, but the main difference is it will place the objects on top of on the roof of the structures that we have specified based on the latitude and longitude. And as you can see, I've already shown you the rooftop anchor selection here. And this altitude offset is basically a relative offset, which means let's say if I enter 10, what it actually meant is, or what it actually means is, it will place the cube 10 meters above the roof, not from the ground level. So this is related to the rooftop, not the ground level. So these are the three possible anchoring methodologies supported by ARCore at this moment. Okay, now let's look at other features that Google has introduced with this new ARCore version, which is version 1.37. So the first one is scene semantics, where based on the machine learning model, it will be able to label different components uh, based on the camera feed that it is getting from the device. Right now, it supports more than 10 labels, like whether it's a building, whether it's a road, whether it's a person, whether it's a moving vehicle, or whether it's a sidewalk. So based on which, as a developer, you will be able to strategically paste AR content, which might be more intuitive while using the application for the user. So I think this is a really good feature which we'll be seeing being utilized by developers in the upcoming VR applications. And streetscape geometry is one of the geospatial API which it relies on. It's kind of so this is the supporting thing for the rooftop anchors, and also geospatial depth, and also it also supports Vulkan API going forward. Right now it's on OpenGL. With now right now we are going for closer support Vulkan API, and electronic image stabilization is also introduced now, because as an you are expected to move around in augmented reality. Google claims it has reduced the jittering, or the new output is 20 to 30. I don't remember the exact number. I saw the keynote there. They have mentioned a significant improvement in terms of stabilization, and I think it's a really a good sign. I'm really happy about that, and I think I have covered pretty much every new feature that I wanted you guys to know. So yeah, that's it. I'll be also making an development tutorial based on how to utilize these features on Unity. So don't forget to like this video. If you have any doubts, comment down on this video. Don't forget to like, subscribe, and bye bye.